Hello Year 11s, welcome to the last exercise from chapter 14. Okay, so 14.0, applications of circular functions. Okay, so there's no necessarily new content, we're just applying this to like a real life situation. Okay, so hopefully it makes a little bit of sense. Okay, so question is, it is suggested that the height HT of meters of the tide above the mean sea level in January at Warning is given approximately by the rule HT equals 4 sine pi on 6t, where the number of hours after midnight, where t is the number of hours after midnight. Okay, so we need to draw the graph of y equals h of t. Okay, so to draw the graph, we need to know a few things. Okay, the first thing we need to know is obviously the period. Okay. Remember the period is found by 2 pi over n. In this case, n is pi on 6, so this becomes pi over 6. So if you flip this out, this becomes 2 pi times 6 over pi. Okay, so I've just flipped them to because it's dividing by a fraction. Okay, those pi's actually cancel out, and we actually get a period of 12. And that 12 will represent 12 hours. Okay. We also need to find the amplitude. Okay, the amplitude. So if we find the amplitude, that's just represented by the number in front of the sign, and that's 4. Okay. We need to think about if it's a sine or cos. Okay, in this case it's a sine. So with a sine graph, where does it start? Okay, so it starts at 0. Okay, and we said the period was 12 hours. Okay, so if that's our 12 hours, it goes up, down, and up. But we need to draw this for the whole 24 hours, so it goes up, down, up, and that'll be our 24 hours. And it should look something like that. Okay, each of those sections, remember we break it up into 4 sections. Okay, those top, if we need to find out those hours. But when we draw the graph, it should look something like that. Okay, so it starts at 0. The period is 12. Okay, so 1 full wavelength after 12, 2 after 24. Okay, and the amplitude is 4. So as we drew down here, our maximum height must be 4. Okay, so that's part A completed. Okay, so moving on to part B. When was the high tide? Okay, so we're trying to find the high tide. The high tide was when we go back, it was at these crosses. Okay, so when the maximum was 4. Okay, so the height was 4. We need to find those 2 times. Okay, from the graph we can see that's 3 and 15. If we wanted to find it algebraically though, we have to find it in a different way. Okay, so what we do is, if I find my mouse, there we go. So we go 4 sine pi over 6 t equals 4. Okay, so we're trying to find at what point does it equal 4. 4 divided by 4, that equals 1. So this is sine pi over 6 t. Okay, I'm going to go inverse sine across to 1. Okay, I'm going to try and find solutions where sine is actually 1. The first one is actually pi on 2. So if we draw a little unit circle, okay, the first one is pi on 2. And we don't get that until we do another full revolution around. Okay, and find the second solution, which is actually 5 pi on 2. Okay, it's not 3 pi on 2 down here because that will be negative 4. We're trying to find where it's positive 4, so be very careful. So we have to do another full revolution. Okay. Now what I'm going to do is I'm going to bring the 6 pi across. Okay, so this becomes pi on 2 divided by pi on 6, comma 5 pi on 2, comma divided by pi on 6. Ignore that. Okay, so what we're going to do, visualize that you're flipping it. Oh, I could write it here. So pi on 2 times 6 on pi, comma 5 pi on 2 times 6 on pi. Okay, so when we bring that across, those pi's cancel out, and this becomes 6 divided by 2, which is 3. And then the next one, we got those pi's cross out. Yeah, 5 times 6 is 30. 30 divided by 2 is 15. And these are the 2 times that we're at the high tide. If we go back to our mathematics, That's what, back to our graph, sorry, that's what we proved with our mathematics. Okay, that time is at 3 and 6. So those are our two high tides, okay. What was the height of the high tide? This is actually pretty full. This is just 4 meters above the mean height. Okay, what I mean by the mean height, I mean where is it symmetrical? Where's our line of symmetry? Okay, so as I draw a dotted line along that x-axis, okay, where does it fall below? Okay, so you need that distance of 4 goes above and then 4 underneath. Okay, so you need that sort of that line of symmetry within our question. Okay, so that's just 4 meters above the mean height. That's how you word it. So don't just say 4 meters, okay, because we don't know exactly 4 meters from what, like above what. So the next one says, what is the height of the boat at 8 a.m.? Okay, so what we're going to do is, if we look at our formula, okay, so what we're going to do is we're going to go h of 8 into our formula. So this becomes 4 sine pi on 6 times 8. Okay, so remember that 8 a.m. is 8 hours after midnight. Okay, so if that was 8 p.m., okay, remember that the question stated that it's after midnight. Okay, so if it's 8 p.m., you actually have to put 20 into the formula. Okay, you would generate the exact same value, okay, but because the period is 12, so you're only adding 12, so it doesn't really change anything, but mathematically you'd lose a technique mark. Okay, to simplify this becomes 4 sine, so 8 over 6, that cancels out to 4 on 3, so 4 pi on 3. Okay, sine of 4 pi on 3, remember that 4 pi on 3 sits in the third quadrant. Okay, so it's in the third quadrant, so this becomes 4 times. Sine is negative, okay, within that quadrant, and it's actually negative square root 3 on 2. Okay, they correlate, so that comes to 2, that goes to 1, so this becomes negative 2 square root 3. Okay, if we actually wanted to find the actual distance, you could put that into the calculator, but an exact value is pretty fine, but negative 2 square root 3 meters. Okay, so we need to add the units. Don't forget the units, otherwise you lose the mark. Okay, the last one, for E, the boat can only cross the harbour when the tide is at least 1 metre, okay, above the mean sea level. When can this boat cross the harbour? Okay, so what you need to think about is visualise what we're looking at, okay. So as we have our graph, remember our graph from the slide before, we got 1 and 2. Okay, so remember that was 24 hours, that was 12, so that would be 6, that would be 18, okay. What we're going to do, remember that peak was 4. This boat can only cross when the tide is at least 1 metre above the mean. So where 1 is, I'll change colours with this, we'll go green, okay. If I drew a very average straight line, okay, what we're trying to do is we're trying to find where these two lines intersect, okay. So during this period where these two lines intersect, the boat can cross the harbour, okay. What we need to do is we need to find these locations and where do they sit, okay. So from there to there, there's some period of times of the day where we can find that, okay. So if I go back to my blue pen, okay. So what we're going to do mathematically, okay, we're going to solve this mathematically. So 4 sine, we got pi on 6t. What I'm going to do is I'm going to make it equal to 1. Okay, so if I bring this across, a sine pi on 6t equals a quarter. Okay, what I can do to generate all of my values, okay, what I might do is I might bring up my calculator. Okay, so if I go to my calculator, I'm going to go to my main screen. I'm going to clear that from the previous slides. Okay, so what I'm going to do is I'm going to go solve. So 4 sine, bring up the fraction tool, so pi over 6. Instead of using t, I'm going to use x. Okay, I'm going to say when that equals to 1. What I'm going to do though is I need to be careful. Okay, I need to generate a restricted amount of values. Remember the sine function, there'd be an infinite amount of solutions. So I need to restrict it. So I'm going to go to math 3. I'm going to press my given that symbol, that little vertical line. and I'm going to go, our domain is 0 less than x less than 24. Okay, so I'm trying to find my values within those first 24 hours because that's what my whole domain is, because we're trying to find within the first 24 hours. What I can do, I can press equals and actually generate a few of these values. Okay, so if I go there, no, we don't want that exact solution. What we're going to do is we're going to keep those values there. Okay, so what I've got is 4 values. I'm going to write these down down below. So just give me 2 seconds while we copy them down. So what you should get is t is equal to 0.4824. Next one is 5.5176, 12.4824, and 17.5173. Yeah, I think I can read my own handwriting. Okay. What we need to do though is, these are decimals, okay? What we need to do is we need to find an actual time. So if you handed that to someone, go, you can only pass it at 0.4824 hours, they're going to be a little bit confused, okay? So what we're going to do is, how we convert to hours and minutes, okay? What we've got is that 0 represents 0 hours, okay? And that 0.4824, we're actually going to convert to minutes. How we do that is we go 0.4824. I'm going to multiply that by 60. Okay, so I get 28.944. I'm going to round that off, and that's going to be rounded to 29 minutes. Okay. Okay. As you repeat that process, the next one would be 5 hours. Okay. If you go the 0.5176, you multiply that by 60. Okay. Don't include the whole number because we're not converting the hours to minutes. You get 5 hours and 31 minutes, so 5:31 a.m. as the time. The next one you get is 12:29, and the last one is 17:31. Okay, so those are the times. Those are my intercepts. Okay, so those are the 4 points that I said I needed to find, and I did find. Okay, but again, when can this boat pass the harbour? All I've given you is the times. Okay, now we need to put this into something that makes sense. Okay, so what we can do is we can go, therefore, the boat can only cross the harbour between 0.29 comma, sorry, not comma, and 5:31. I don't know what's going on. There we go. Computer's a little bit glitchy today. Go back to my pen. So 31. Or between 12:29 and 17:31. Okay, so just so we can interpret, so we're not including a period underneath. Okay, we're not including that range because obviously the boat can't pass the harbour during that. It's only between these two sections up the top. So we need to interpret those solutions. So the boat can only cross the harbour between 0:29 a.m. and 5:31 a.m. Okay, this is in like 24-hour time, or between 12:29 and 17:31, so using 24 hours. Okay, so that's just an example of what you might come across. Please make sure you're interpreting your answers and you're drawing everything where required. Okay, so they can be a little bit tricky, but hopefully they're not too much trouble. Okay, so once you finish 14.0, move on to the chapter review. Okay, the chapter review will need to be completed before you come back next term, as well as the chapter 16 slides, which you'll have for homework, which are reasonably straightforward. Chapter 16 shouldn't take you too long. Okay, so then from the very first day, we will be starting chapter 17, and you will have a sack on this in your second week, but I will communicate that with you at another time. Okay, so thank you for listening, and hopefully you enjoy.